Okay, so we're still on quadratic equations, still in 9.1, but this time we're going to take a look at another method of solving quadratics. Notice that our equations are a little bit different now. Now they're kind of in standard quadratic form, at least this one is, ax squared plus bx plus c equals 0. So you might, looking at these equations, you might think, well, factoring is going to be a good tactic. Right? Well, bad news is in both of these cases, at least in this one, I'm pretty sure in this one as well, that factoring isn't going to be an option. No matter how hard you try to factor this, you're never going to be able to break it down into two nice binomial terms, binomial expressions. So we've got a couple ways to handle it. In 9.1, we're going to handle it by a technique called completing the square. And later in Module 9, we're going to learn about the quadratic formula, which is another way to tackle them. Both are acceptable. This way kind of dovetails into the last method that we saw from 9.1, the square root property. So we're going to turn these problems into a square root property and then solve them just like we did prior. So again, this method is called completing the square, and the setup is important for completing the square. It's got some very strict guidelines in order to start completing the square. Right, it's kind of like factoring. In order to factor, it needed to be in standard quadratic form. We always needed to make it equal to 0 before we started factoring and solving. Right, so for completing the square, we need equation in the form x squared plus bx equals c. Okay. Notice I can't even have an a term here, and in order to start completing the square, we need to cancel out or somehow eliminate any coefficient of x squared that I have. So specifically in example number 2, this 2 is going to be a problem that we have to handle before I start completing the square. All right, once it's in this form, right, and notice it's not equal to 0 as well, we're going to put our constant term on the right side of the equation, or on one side of the equation. Okay. All right, once it's in this form, right, we're going to find, let's see, for lack of a better term, we're going to be adding something to both sides of the equation, and we just have to find the value that's going to work the best for us. So. So let's see, find the missing addend. I don't know if that's the correct term, but I'm going to call it the missing term that we want to add in. And how we find it, it's always going to be the same place. We're going to use this coefficient b. Right, so whatever the coefficient of our x term is, or our middle term, right, so in this case it would be 6. Right, we're going to take that b value, divide it by 2, right, and then whatever that b value divided by 2 is, we're going to take that value and square it. Add value to both sides of the equation. Okay. Seems a little bit weird to be adding something to the equation that doesn't cancel anything out, but what that value is going to help us do is it's going to help us factor the quadratic side. So factor the quadratic side. And once you have that factored, it should be should is probably not as strong of a word. It will be a perfect square trinomial once you add this missing piece in. So every single time that you add this missing piece, you're going to have a quadratic that is factorable, and not only is it factorable, it's going to factor into two identical binomial pieces, right? So that's always going to happen. And then once we are able to factor it, we're going to be able to solve using the square root property. Okay, so this goes back to what we just learned. So it's kind of one additional step, a few additional steps to set up the problem to use the square root property. All right, so let's do two of these problems pretty quickly, all right, and let's follow these steps if we need to take them. All right, first, we need the equation in the form x squared plus bx equals c. All right, and notice this one isn't quite that way. All right, I have x squared plus bx, but this constant term has to be on the other side. So I'm going to just subtract 1 from both sides. All right, and I'm going to leave a gap. I'm going to leave a little gap in here because I know what I'm about to do. All right, is I'm going to, let me even put a little underline there so we can. All right, I know I'm going to put a value here. I'm going to add something to it, and I know I'm going to put a value here. I'm going to add something to that -1. So there's two little blank spaces in there. I'm going to put a value in. We just have to figure out what that value is. So it's b over 2, and I'm going to square it. So from our problem, our b value is 6. So 6 over 2 squared is going to equal, that'd be 3. 3 squared is 9. So I'm going to add 9 and add 9, right, to both sides of the equation. Right, and this will always work out if this value is found correctly, that this factors perfectly into x plus 3, x plus 3. Right? 3 times 3 is 9, and 3 plus 3 adds up to 6, so we can see that it works out perfectly. And it's also not coincidental that this value right here that we're going to plug in, not that we can't factor this just by thinking through it, this plus 3 and plus 3, where is it always going to come from? b over 2. b over 2 is 3, so I know I'm going to have plus 3 plus 3. On the right side, that's going to be an 8. And now we can just rewrite this as x plus 3 squared is equal to 8. And now we've turned it into a square root property where I can square root both sides, not forgetting my plus and minus. This would be, oops, no need for parentheses anymore. X plus 3. Over here, we can simplify this. Plus or minus 8. Square root of 8 reduces into 2 root 2, because that's 4 times 2. And then we can just subtract 3 from both sides. And x equals -3 plus or minus 2 root 2. And there are 2 solutions to that quadratic. Okay. That's pretty much the idea behind solving using completing the square. I think, from my perspective, it's the most labor-intensive method of solving a quadratic. Right, in the next section, or the next couple sections, we're going to see another way of solving this, which I think is a little bit more accessible than this. All right, this requires a lot of steps to remember how to do, but there's a couple other ways to do it. All right, let's try number 2. It's already on its way to being in the correct form, but it's not quite there for another reason. Right? This one, we needed to shift the constant over to the other side. This one, the issue is my coefficient of my squared term. Right? Notice I can't have a coefficient of my squared term. So the first thing I need to do in this equation, right, is divide everything by 2. I can already tell this one is not going to be very nice to work out. Let's see what we have. Now we have y squared plus 5y. Right, I'm going to leave a little gap here. Negative 7 over 2, and I'm going to leave a little gap here because I know I'm going to add something to both sides of this equation. That something, we're about to find out, is going to be b over 2 squared. Right? And now that it's in the correct form, my b value is 5. So it's 5 over 2 squared. Right? And we can square both of these, so that's a 25 over 4. Add 25 over 4 to both sides of these, both sides of this equation. Okay. And although it's not very nice, this left side, it is very factorable into a perfect square piece. Okay. And the hint that I gave you back here, although this is very straightforward to factor, 2 factors of 9 that add up to 6, right? Maybe it's a little bit harder to find factors of 25 over 4 that add up to 5. Right? So, if you remember, this b over 2 value, whatever that value is, that's going to be your perfect square factor, because 5 over 2 times 5 over 2 is 25 over 4. So that's going to be in our factorization, and it's just going to be x plus, or sorry, can't be x anymore. The equation has y's in it. Oops. Oh yeah. And then on the right side we can add these two up. So we need a common denominator. That'd be negative 14 over 4. Negative 14 plus 25 should be 11 over 4. So we have y plus 5 over 2 squared equals 11 over 4. We can use the square root property with a plus and minus. We have y plus 5 over 2 is equal to plus or minus the square root of 11. I'm going to leave the square root of 11 on the top, but the square root of 4 I can reduce to just 2. And then solve for y. We can subtract the 5 over 2. And there's our two solutions from completing the square. So there's a few in there that'll get you some practice completing the square. But the key thing is that it needs to be in this form. If you try completing the square and using 10 as your b value, it's not going to work out. Because you're not going to get perfect square factors with this coefficient of 2 in the way. So always remember to put it in the right form and then go from there.